What comes to mind when you first hear the word string theory? Do you think black holes, Gerard T. Hooft, Stephen Hawking? If you don't think any of these things or think that string theory is actually a theory, then you are thinking wrong. String theory, according to the physicist Gerard T. Hooft, who we'll talk about later, should not even be called a theory. According to T. Hooft, he would not even be prepared to call string theory a theory, rather a model, or not even that, just a hunch. String theory, according to Gerard T. Hooft, shouldn't even be referred to as a theory, just a hunch. T. Hooft said, actually, I would not even be prepared to call string theory a theory, rather a model, or not even that, just a hunch. After all, theories should come together with instructions on how to deal with it to identify the things one wishes to describe. In our case, the elementary particles, and one should, at least in principle, be able to formulate the rules for calculating the properties of these particles, and how to make new predictions for them. Imagine that I give you a chair. While explaining that the legs are still missing and that the seat, back, and armrest will perhaps be delivered soon, whatever I did give you, can I still call it a chair? According to De Hooft, to be able to refer to string theory as a theory, there should be a way to actually perform some math that can prove or disprove it. Black holes have a special place in string theory and physics. Black holes were first viewed by Stephen Hawking as destroyers of information and anything else that fell in. After taking 20 years to advance enough to weigh in, string theory has become an intermediary viewing lens of black holes between general relativity and quantum mechanics. The view of black holes through string theory provides a sort of happy medium that hypothesizes black holes as containing little strings of information. Stephen Hawking was wrong about black holes. They don't destroy matter and information, they possibly conserve or displace it. Hawking forgot to account for the laws of conservation. According to Leonard Susskind, string theory cannot properly function from a viewpoint limited to only 3 dimensions. String theory requires a universe with at least 10 dimensions, according to the equations describing superstring theory. The 3 basic dimensions that can be imagined are the planes of x, y, and z. Those dimensions are planar dimensions. X is left and right, Y is up and down, and Z is forward and backward. So with only these planar dimensions being what we know, it is hard to imagine a 4th or 5th dimension of plane, let alone 10 or 11 of them. In conclusion, string theory involves the worlds of black holes, Stephen Hawking, and Gerard T. Hooft. In the world of black holes, string theory disproves Hawking's theory that black holes destroy information and matter. In the world of T. Hooft, string theory shouldn't even be able to be referred to as a theory, rather as a hunch, because string theory cannot be supported by information because it provides no way to support itself as a theory. In the world of Stephen Hawking, string theory is the devil himself because it is able to disprove his theories.